All right. Thank you, everyone, for joining. We'll go ahead and get kicked off here as well. So I appreciate you all joining our next installment in the webinar series here, where we're trying to simplify things for you guys with water quality instrumentation. So us here at Water Analytics, we produce the Aquametrics product line. They will be talking about simplifying conductivity. So we have the chat enabled today. We have a little bit of a more kind of intimate session where want to have you guys reach out as well if there's use of conductivity or how it's being used in your life. Feel free to post that up in the chat as well, and when we get to kind of the Q&A session, we can dive into that. I'll also note, if you do have any questions, feel free to post it at any given time into the Q&A. And at the end of the session, we will be able to address that. So again, appreciate you all attending today. Let's dive in. Our main value proposition when it comes to our sensors is instrumentation that works when you need it to. And we really love to stand by that because we've had great success with our products over the years. So the Aquametrics product line has been in the market for over 50 years, and Water Analytics has been a company for over 15 years. And we still have some installations that are just running strong and running for a long time. As you may have seen from the other presentations, we have some installations that are 10 plus years running strong. And we really do believe in it. And our conductivity sensors are no different. Right? This is where our products shine, and this is where our products can really deliver to you and to your customer base. Today, our focus is going to be simplifying conductivity. And these are areas where we feel you can impress your customers by learning a little bit here. So similar to the pH training we did last month, these are things that you guys can look like experts within 20 minutes, right? That's our goal. Within 20 minutes, can you become someone that can go into a facility, go to a customer, and talk enough of the talk to seem like you really know what it's like with conductivity? Someone in the call may already have that experience, and this will be a breeze for you. But again, we want to make it really easy for all of our customers to be able to understand what conductivity is, because sometimes conductivity becomes a little bit complicated. So what are you measuring? That's a great first question to come up with it, right? Now, we said this is a presentation on conductivity, so why would I be asking you, what are you measuring? I'm measuring conductivity. Well, the word conductivity sometimes means different things, and conductivity sensors really do mean a few different things in what they're able to deliver. It's all the same measurement, but it's really about how we're talking about it. Let's start first with total solids. Total solids is really a function of two different things: total dissolved solids and total suspended solids. And for the most part, the way you're going to be measuring these from an analytical water perspective is going to be TDS is conductivity and TSS is turbidity. You can measure these in more precise methodologies where you are, removing all of the water filters and that, and people do get really precise calculations. But for conductivity, and you're converting that to TDS, right? That's what a sensor is doing. It's not actually taking the water out of the equation and weighing and measuring the solids that are in that water. So what does that mean to you guys, right? Do you need to know all these details? Not necessarily, right? It comes into what is the equation and calculation for conductivity to TDS. So if you see something like this, you might start to get a little nervous or scared and say, this is a little bit more complicated than I want. Well, we want to, again, simplify things for you guys today. So when you look at the graph and you dial in into the area of most of the applications where you're measuring, you can see that you actually have these straight lines. It goes from these complicated looking curves to these kind of straight lines, and it comes up with what we like to say is K is okay. And I don't know if anyone here knows what K is, but K is really that coefficient that's able to convert your conductivity value to TDS. For the most part, kind of the standard number is going to be 0.65. That becomes the K value that most sensors and most manufacturers will use in the industry, their conductivity to TDS. TDS. As you can see from this graph, you can adjust that and change that. So to make yourself seem like an expert in conductivity, you can highlight, right? If you know your customer is measuring TDS, you can highlight this is the way that TDS is calculated. We're using this coefficient of 0.65, but if you'd like to change it, we can adjust it. And it's a nice part of our sensors and our controllers you are able to adjust that coefficient. And the best way to do that, right, is they do take a sample at one point and they take a measurement and they realize the relationship between the conductivity value and the actual TDS is 0.61. Then you can plug that in. You have that moving forward, especially in stable conditions. It can work really effectively there. But again, coming back to it, K is okay in almost all applications, and most people don't really even know these technical pieces behind it. So another big impact to conductivity readings and TDS readings is the impact to temperature. Temperature plays a big part on this. And one of the things that sometimes gets hidden behind the scenes with conductivity sensors is whether it's compensated or uncompensated. And so looked at kind of this graph here, you can see a lot of sensors out on the market are pre-configured to be temperature compensated. What does that mean? Well, that means it's going to be a relatively stable reading at all temperatures. You can see here in this orange graph, you're going to be getting the same conductivity readings throughout that whole range of measurement. It's not going to be dependent on the temperature, but the raw reading coming out of it is looking more like that blue line where you can actually see what the readings are outside of what the temperature is. And this is an important distinction to note because some measurements may want to be using temperature compensation and some don't. Most conductivity sensors out of the box are going to be using 2% as the standard typically is around 2.05% per degree C. So you have to ask yourself that question, is 2% good for you? If it's not, you can adjust it. It's a nice parameter with this as well. You can look at where your solution and your processed water is at, right? Is it an acid? Is it a base? Is it a higher concentration of salt? The coefficient changes at that rate. And you can see here the percentage is a little different on each one of those. Similar to the TDS coefficient, if you're happy with what the K value is and you're happy with 2%, then right out of the box, your sensor can be good. So pulling it all together, you have choices and you need to understand what you're trying to measure. And you can simplify it down really into these three simple boxes. Do you want the raw conductivity, which is measured typically in microsiemens per centimeter? Do you want the temperature compensated, which is again the typical default value that sensors are going to output using 2% as your temperature compensation? Or you want your TDS value, again, default to your 0.65 for your K and 2% for your temperature compensation. With simplifying conductivity, and you want to get more precision or you want to look a little bit smarter, you can ask them those questions to see if they want to improve some of their resolution, especially if they're not happy with their current incumbent solution. There's a lot more choices that come into conductivity. So those are some of the fundamentals and basics that really help you understand what you need to do. But there's some pitfalls that a lot of people do. So the number one mistake that buyers make isn't around, do I have the right TDS value? It's not around, do I have the right, temperature compensation? It often is, do I have the right cell constant? So for those that may not be as familiar with the cell constant, really the simple way to think about that is what is the range? And you can see here from this slide that clearly wasn't updated, unfortunately, but it should highlight here what the different cell constants are. And you can see here in the purple denotations with our naming of the ASM or the ASTX series is you have your 01, your 1, your 10, and your 50. Those correspond to your cell constants. And that really is where you can see where your measurement range is. And that's why it's really important to know what you're trying to do. And it does play into your TDS as well, because understanding, are you measuring in conductivity or are you measuring in TDS, helps you understand where your ranges are, because you need to apply that decay factor. And so picking the right cell constant is really going to help you be able to determine where your range of measurement is and making sure you're set up for success right out of the box. But outside of cell constants, there's something called the toroidal sensor. The toroidal sensor really is that wide range application, and that can start to cover a much broader range of where it is with one sensor. So you don't have to worry about what that cell constant necessarily is. To help look at it in this view as well, removing the sensors and thinking about it in a more of an application standpoint, which is probably more the way that you and your customers will be thinking of this, is what's the right cell constant for the type of water that I'm using. So you go all the way down to the end where you have your cell constant of 0.01, and that's really your ultra pure water. And you're seeing more things in your cell constant, 10 is going to be more your brackish water and beyond. And this really helps you understand what type of sensor do you want so you can be successful right out of the gate. If you pick the wrong sensor for the wrong measurement range, you're going to have a really hard time helping yourself or that customer get the right readings. There's more to think about when it comes to contact and conductivities and toroidal, right? So we talked about the range of their measurement, and that's a big part of the application to it. But another big part is how are you installing? What is the type of water that you're being put into? And fouling can be a big problem for some of the contacting sensors. So you have a little bit of scale, and you might see a little drift. But on toroidal, it's going to have very minimal impact to that. You may have a little bit of biofilm on the contacting sensor. Again, you're going to see drift on that. And you can see from these pictures here as a nice little example of just what that could look like. This is a bit of an extreme example to showcase it, although we do see this every once in a while in some applications. If cleaning is not done, that can be an issue. And without going through all the different examples here, the cleaning becomes your question, right? How frequently do you want to clean in your application to get the measurements and readings that you want to achieve? Because sometimes the toroidal sensor can help with that, right? You can have that sensor running for a longer period of time in between maintenance cleaning because it has very minimal impact to the fouling of that process. You have a nice clean water process and you know exactly what range you're measuring, right? So you know your cell constant. The contact and conductivity sensor may be a better application for you because you can get a little more resolution knowing that you're honing in on a specific range. There's another big consideration when you're thinking about toroidal versus contact and conductivity, and it's something to think about with conductivity sensors as a whole. This is across the board. It's not specific to our products. Our numbers may be specific to us, but generally everyone's numbers are around the same, and it's an important thing to think about in terms of location matters. So when you look at a toroidal sensor, you can see from the little graphic here, you need about 1.5 inches all the way around to get good proper readings. Anything within that frame, let's say that's a pipe, let's say that's some sort of rod or something that's just in the process, it's going to alter the readings. Same thing with a contact and conductivity sensor, and this is something you guys could always do in either one of these, right? You have it suspended in a solution and you're reading, and you put it all the way down to the bottom, and you touch off where the electrodes are, you're going to change your readings. You typically see about 1 inch is where you can be protected, that if you keep that down below, then you're not going to have an impact to your readings. Now, you may say, well, I need to have my installation in a way where I'm infringing on this. There's just no way around it. I need, let's say a 2-inch pipe, and you need to have the toroidal sensor, right? That's what you need for your application. It's okay. You can calibrate around that. Typically, the interference seen by that third-party force is constant, and you can calibrate around that. But you need to know you need to calibrate around that. So if you were to pull a sample right out of the box and you didn't calibrate for that, you may need to perform local calibration. Again, something to think about with sensors that you get that are pre-calibrated. You just may need to perform that simple calibration on site, and then you're back up and ready to run again. Mounting again becomes really important here as we've discussed, and that's something we can help you guys with of what's the right application, what's the right methodology. Again, thinking about location, thinking about the fouling, right? You need some better flow with it. How are you going to remove it? Is there temperature constraints? So you can want to be able to take it out maybe for CIP purposes. But the way you install it can be really impactful to making sure that it protects the life of your sensor and you get you the proper readings throughout that whole range of that sensor's life. The other part of a big decision here is going to be your smart or dumb. Right? So really simple in terms of its view here. You have your dumb sensor, which is what it's outputting. It's just that raw reading. It's giving a reading to a device that most of us have no idea what that means. It's going to be a raw voltage that just honestly doesn't make a whole lot of sense to most people. And that's where an analyzer or controller solves that for you. Then you have a smart sensor, and that sensor actually brings that intelligence inside and it outputs it typically as an analog or a digital output. And that allows an end user to see that signal on a more regularly, easily accessible perspective. The other big part of a consideration with this can become cable resistance. So conductivity is an inverse relationship to resistance. And that being said, as you start to have longer cables for your raw sensors, you can sometimes have an impact to the readings because of the cable resistance, where your smart sensors can eliminate that. Now, again, most sensors can work through and calibrate that out, but again, it's something to think about in terms of your application, your process. Do you want to handle this, or do you want to just be able to bypass it and have an easier solution for your customer? Smart choices in terms of your calibration. All of our sensors that are smart are coming out of our factory 100% calibrated and ready to go. You get your calibration to start with that. The smart sensors can also be calibrated on a computer or at a local controller or the PLC. Again, the dumb sensors can be calibrated at your controller. Calibration for conductivity can be really simple, right? You can do a grab sample or you could have some calibration standards and be able to test it in with that. For the most part, you can get away if you don't care too much about the level of accuracy and you're okay with a roughly 5% range. The 1-point calibration can kind of keep you up and running. We always do recommend a 2-point calibration because it is going to give you a little bit better accuracy and it's going to give you a little bit better resolution as well to make sure you're not missing anything in terms of your process. I threw a lot at you guys with the different parts when it comes to the sensors and how it all comes together. And the point of today's presentation was to not make this complicated, right? So I want to simplify this. And that's the nice part with the connectivity sensors is you can bring it all into one table and you can think about it from a very simple standpoint of what is your decision process. What are the drivers for your customer or for yourself if you're installing this so you can pick the right sensor. And this is really important because picking the right sensor is one of the biggest hurdles to get through. If you can pick the right sensor, you can pick the right way to install it, your application can be really simplified from there on out. Connectivity sensors are really robust and reliable and will last a long time if you get it right out of the gate. And so a nice little decision matrix like this can be really helpful to make sure you're going through it. And it's, again, thinking about all the parameters we talked about throughout this presentation. As I mentioned, these sensors can deliver all this. Most sensors on the market are really reliable as well, but why Aquametrics? Why our part? I have to give a little bit of plug to us here, and for us, it comes down to the quality control the Aquametrics way. All of our sensors are tested and calibrated here in our factory, and you can get a calibration cert for our smart sensors. And all of our dumb sensors are also tested, and we keep record of all of those parameters. And not a single sensor leaves this facility without being tested. And so that way, again, the most important part is picking the right sensor, getting it ready to go, getting it set up. And the big part that comes into that is it working out of the box? And thinking back to the importance of what we note, that our instrumentation works when you need it to. The time you need it to is right out of the box, and that's what we want to help deliver to you. And so that's really, again, what we stand by. All of our sensors do it, and our connectivity sensors follow through with that as well. And last, if you guys want to learn more about conductivity before we open it up to questions here, reach out to our team at any given time. So here's some contact information for the team here, myself and Mark G here, who's sitting here with me, and I'll bring him in for the question and answer portion here in a minute. Reach out to us at any point, because what we really like is working through this with you. You call, you're going to get a person. One of us is going to pick up the phone. If we can't pick up the phone right away, we will call you back, and we will talk through these questions and applications with you. So that being said, I'll open it up here to a question and answer portion for anyone that may be here on the call. Mark, are you seeing any questions coming in here?
Question. You talked about the 2-point calibration, and the question we have is, do we offer calibration standard solutions for connectivity?
Great question. So we have taken that off of our price book, but that is something we can continue to provide for you guys as our customers. So that is, if you are looking for a connectivity solution, you can reach out to us, let us know what's the ranges, and we can make something within that range. Part of where we've taken that off is just in terms of making the standard. We do test all of them in-house, and you'll get kind of you will get a precise value that's tested and calibrated in-house. It may just be a little bit different than a standard, because we are making each one of these fresh batch for all of you and to order.
And obviously, those will also have the same quality standard with the calibration certificate.
Yes, we will put a certificate with each one of those as they leave the facility, so you'll know exactly what you're getting.
Another question we have is actually related to resistivity. If you have an application that requires resistivity measurement rather than conductivity, how would we handle it?
Yeah, so the easiest way to do it is probably going to be through switching the value. So with a smart sensor, you can get your input out and go into a control. You can provide that inverse, and you can look at it from the raw on temperature compensated perspective. But that's one of the things where I would say, if you have an application, because it's not a measurement that's typically taken in the water industry, most people are thinking about it in terms of temperature compensated connectivity or in terms of TDS. I would say it would be worth calling us, and we can help walk you through that to really understand what their needs are, what level of resolution, how they want to be measuring that, and how they want to be using that measurement. That's the really important part. Getting into the heart of all this is most people are not measuring connectivity to simply just know their conductivity value. It's a little bit different than something like pH, where you actually may want to have a specific pH range. You're doing the conductivity as a driver for typically something else. And that's why I would say it's important to understand, if you're getting a question around resistivity, is finding out what is that driver. We can help them make sure that you're getting the right proper measurement with it. But our sensors would be able to help with that.
So yeah, it looks like we don't currently have any other questions at the moment, which would be a testament to the good job that you did presenting here today. If anything else comes up, obviously we're sharing our contact information. Like Ryan said, we have a pretty good team here between Ryan, myself, technical engineering, Mark as well, Mark Spencer. So if there are any questions regards to any different applications that we didn't necessarily mention here that you might have, feel free to reach out. We'll be happy to help with those.
And again, a plug here for the next session. So this is the second of the three-part of our webinar series. So next month on the 24th of March, we'll be having our simplified control. And we'll talk about our controllers and how that can simplify your processes as well. We'll definitely bring together some of the stuff we've talked about in the pH and the conductivity, but it's really then highlighting how controllers can help add simplification, but also how can you guys talk about controllers in a simple way. So if you haven't already signed up for that session, please do sign up with that as well. And as Mark said, reach out to us at any time. We're happy to talk more about conductivity or any of the other products that we offer into the market, or just simply talk about water. But I appreciate you all taking the time with us today, and have a great rest of the day.
Thank you.